Looks like everybody has at least one person with them. Take about 1 or 2 minutes here and think about the question presented to you, and then we'll pair up and compare, and then we'll finally try to share out. So I'll read the question out loud for you. It says, carefully look at the graph of f of x below. Write down everything you know to be true about the graph of f. Then compare notes with your partner. That's the pair part. And then we'll share out when we're done. I do want you to try to make new observations about any patterns you see involving f prime and f double prime, right? And how it relates to f. Okay, so we're trying to make some connections, and we'll do some key takeaways, the main things I want you to bring with you as we dive into this. So, take a little time. I want you to write down things you think are true about f, as it relates with f prime, or perhaps f double prime. There's lots of good things you can bring in. Try to get them hashed out there. Thank you. And here's what you missed. Solomon says don't have affairs. We have a test on Wednesday and a review day tomorrow. That's it in a nutshell. Investigate with this graph. How does f connect with f prime, connect with f double prime? Anything you see, you think is true, it relates those things. So some things you could be writing down here, you could be saying things like, when f prime is ... f is some other ... right? Or when f double prime does this, f seems to be doing that. Whatever. Statements like that would be really, really good. Trying to connect the two together. Let's take a minute now and compare. So pair up with somebody sitting next to you, and you can switch papers, or you can just say, hey, I wrote this down, I wrote that down. You can compare. There might be some things that you see that your partner came up with and you didn't come up with that you might feel is worthy. So Cole, you and Nate should be talking right now and saying, I wrote this down, or I was thinking about this, but I wasn't for sure. Hand back your local talk quizzes from last time. Yeah, there you go. 'Sorry about that. So L'Hopital quiz is not on your test, so I'm just handing these back to you. This is for future retries, feedback right now. So you really don't need to be doing retries tomorrow or Wednesday on this, but you can start on Thursday, right? I mean, that would make sense. It's got to be before. I just can't spread it out. My life will turn into one task. I want you to do retries, but that's out of a sense of self-preservation, to be honest.
Yeah. Are you?
Yep, I'll be here tomorrow on Wednesday. Yep. Okay, I would love to hear what you all have to think. I'll just be sketching these things down, and then we'll do some key takeaways at the end. Hunter, what do you guys think? What'd you come up with?
Came up with when f prime is increasing, f of x is positive.
When f prime is increasing, f is positive. What do you all think about that? Did anybody else write that down? Do you think that that's really is true? Do you think that that's false? Some reactions to that. I like the way he structured that, right? He wrote, when f prime is ... f is ... right? So maybe you didn't think about this. Maybe you didn't write anything like this down. I want you to really consider, is what he said true or false?
It gets to 0.
Sir?
Well, like when f prime, if it's, say it's quadratic, like, it looks like, I don't know if it would be that much at 0. Like, f is like, y at 0.
Right. I would say probably the flattening out happens at one point.
Okay.
I know it looks like maybe it would happen at like multiple points.
So is that still considered positive up until 0?
Maybe he should have said non-negative, possibly. So let me say this. This is a really interesting statement because for this particular graph, this is true, right? So f is positive. Would you guys agree with me? No, don't write any of this stuff down because we're gonna change this a little bit. Would you guys agree with me that this red highlighted section, f is positive, isn't it? Now let's check this out. Let's just do some really rough estimates. F prime, this is a graph of f, right? What would you estimate f prime to be right there?
Negative 3-ish.
Fair enough. And then how about right in there? What would you say f prime is? Just estimate. Please don't try to give me a perfect answer. -1 makes sense, yeah. How about right there? -1/2. And then right about there, wouldn't we say f prime equals 0? So isn't, like if you think about the pattern from left to right going from -2 to -1 to -1/2 to 0, isn't that an increasing pattern? It totally is. So what Hunter said is true, but I would liken this more to a coincidence than anything else. Can you imagine if, who did our football team lose to? The Georgia team. Cedar Grove. So let's say that you went to the Cedar Grove game. And let's say when you went to the Cedar Grove game, and I don't remember if that was like a whiteout or a blackout or a whatever out, but let's say it was a whiteout. And let's say that you forgot that it was a whiteout and you showed up with like a blue shirt. And we lost. And is that our only loss this year? Okay. So this would be a false connection. You could look at that and say, oh my goodness, I was the only one that didn't do the whiteout, therefore we lost. It's my fault. And there might be some people who would be like, yeah, it's your fault. Come on, don't be ridiculous. Had to do with what happened on the field, right? This is a similar thing. So this is a true statement, but we can't say that whenever f prime is increasing, f is positive. Can anyone think of a counter to this that would disprove this? This would be so awesome if you could do this. Can you think of a graph? What would the graph look like that would disprove this? Hunter wants to disprove his own statement. I love it.
If it was just a linear line in the negative section, the slope would be increasing.
Well, if it's a line, slope is constant. I mean, if you tried to flip this around, then, but I want to take it in its form. I want to find a place where f prime is increasing but f is not positive. If we draw something where f prime is increasing, but f is definitely not positive. Jed?
If you just shift this graph down one for that.
Okay, yes. I wasn't thinking about that, but yeah. If you shifted that down one, wouldn't this part right here disprove it? Totally. I agree. F prime would still be increasing, but there would be a place where f was negative. I totally agree. I was thinking of this. It's not that much different than what Jed said. But what if we had some graph that looked like this? F is clearly negative the whole time, right? But do you see how, I tried to, do you see how F prime is increasing? F prime went from, 1/2. F prime is 1. F prime is 2. Do you see how F prime is increasing? Yet, all the F's are negative. So, I want to do this. I hope you guys, I really, honestly hope that you all understand the value of what we just did and hopefully what we'll keep doing here. But you're trying to think of counterexamples, like you're digging deep and trying to understand. If you can do that, you'll have this mastered in no time. I do want to do this. This is a nice place to start. I'm going to erase something. Please watch. If I were to start off my statement of when f prime is increasing, I could say that f is, what would be the appropriate way to finish this that's always true? This is actually from last time. If f prime is increasing, f has to be concave up. There it is. F is concave up. So we want to try to make connections that are always true under any circumstances, or all the ones we can think of at least. And that's one of them. Okay. It's always unexpected. I love hearing your guys' thoughts. This is great. What else did you write down? Hunter, thanks for starting the ball rolling. Let's keep the ball rolling. What else? Luke, go.
When f double prime is decreasing, f is concave.
When f double prime is decreasing, f prime, is concave down. I have that correct? Okay. Same thing. Let's talk. What do y'all think about it? When f double prime is decreasing, f prime is concave down. This is where you're going to say, yes, it's right. No, it's not. Or can anybody express what you're thinking? Is anybody thinking, no, that's totally wrong? Is anybody thinking, yes, I think that's completely right? Okay. Is anybody thinking, I don't know? Okay. Fair enough. So let's see here. How do I want to attack this? I would say, I don't know. I want to be creative here. I'm falling short of being creative. It's not right. I'll just say it. I'll just come right out and say it. Let's see here. I don't know if there's going to be many times, if any, when we're going to be looking at where f double prime is decreasing. Not that it's bad, but we just won't have too many occasions to do it. We will definitely have an occasion to say this. And so this is what I would like to focus on, because looking at f double prime here and trying to connect it with something is good. I would say we're going to be looking a lot at where f double prime is either positive or negative. And it's really easy to confuse positive and negative with increasing and decreasing because, like I said last time, sometimes we speak in snippets or we think in snippets. We just say positive, increasing, negative, concave down. But I would encourage you in the strongest possible terms to write and think and speak in complete sentences. And you're trying to do that, right? You actually wrote a nice complete sentence there. But I would say this. Let's see if we can finish this. When f double prime is negative, I'll kind of go along with the same theme. When f double prime is negative, that does not mean that f prime is concave down. What does it mean? Okay, let's do that. I would agree completely with that. When f double prime is negative, f prime is decreasing, I think that is 100% true. That's based on the fact, isn't prime just the slope of whatever it is you're priming? It's not really good terminology, but does that make sense? If I put a prime on something, I'm basically saying, what's the slope of that thing? So isn't f double prime simply the prime of f prime? Or the slope of f prime? That's the thread that connects all this. And there's one more level. When f double prime is negative, f prime is decreasing, and f is concave down. There it is. This is a pretty nice statement. This incorporates a lot of stuff. A whole lot of stuff. This is really good. Okay. Just debating about my time. This is really, really good. These are some, we're tightening these up. These are some really good connections here for sure. But I feel like I need to give you some key takeaways, but I want to lead you to them. Go ahead.
Could we also just flip that and say when f double prime is positive, f prime is increasing, and f is concave up?
Perfect. Yep, that's exactly right. That's exactly right. We're not going to get, honestly, I wish we could do like a 2-3 hour class, because we could probably get all of this perfect right here, right now. Because we only meet for 50 minutes, we don't have that luxury. We'll keep at it for sure. Okay, so let me try to lead you to this. In terms of concavity, how would you describe the concavity of f on the red part? Concave up. How would you describe the concavity of f on the purple part?
Concave down.
Okay. So here is an observation. I'm not going to call this a key takeaway. I'm going to have some other ways to put this. But here's an observation. When f changes from concave up to concave down, or vice versa, right? Concave down to concave up. We could reverse this. Then we would say that f, this is a new term for you, has an inflection point. And I feel like it was like Luke, or I think it was Luke brought this up. He said, around 0, it looks like it kind of flattens out, but it looks like it, the slope of f would be 0 for like an interval, like a whole stretch of points. And I said, I think the way that I drew this graph, I think I drew a cubic here. That's how I think I generated this graph, just like a negative cubic. So this would have a single point right there at x equals 0, in which the slope, or the f prime, would be 0. And that would be the place of the inflection point on this particular graph. This would be the place where the graph of f goes from concave, oops, there should have been an up in there. There we go. The graph of f went from concave up to concave down, or if a graph went from concave down to concave up, that would be what we call an inflection point. Right? So where the graph kind of bends. And would you agree with me that like right there around the origin, doesn't it seem like the graph wants to like make a parabola? It's trying. It's like, okay, I'm bending towards being a parabola. I'm gonna do one of those and be the parabola I always wanted to be. And then I just bent right back down the way I was going. Right? So it's like it tried to bend back upwards, but instead of bending back upwards, it just continued on down. That's a description of an inflection point. Please, on a quiz, don't say, oh, it's the place where the graph wanted to go down or wanted to go back up and then just went down. Like, I'm just giving you descriptions here. This is far from rigorous. I'm sure you can tell. Rigorous mathematics statements. Don't call it a bendy point or an almost curved up point. These are all like nice descriptions, but it's not really what we call it. Okay. Let me give you some key takeaways. This will go nicely with some of the things you guys said. So key takeaway number 1, if f prime changes from increasing to decreasing, or decreasing to increasing, F, F has an inflection point. If F prime changes from increasing to decreasing or decreasing to increasing, then what you have at that place of change is an inflection point where the graph kind of bends but doesn't turn around. Anybody take a wild guess at what the other key takeaway is? It has to do with F double prime.
F double prime goes from positive to negative or negative to positive. Yeah, that's an inflection point on that.
There it is. If F double prime changes signs, right? From positive to negative or negative to positive, F has an inflection point. So you kind of have a game plan for finding inflection points in two different ways. You could use F prime to help you discover an inflection point. You could also use F double prime to help you discover an inflection point. Which one would you choose to do? Honestly, it kind of depends on what you're given. If you're given a lot of information about F prime, like a graph or an equation or something, I don't know about the equation, but for sure a graph or maybe a table or something, I would just use the F prime reasoning. But if you're given an equation or you're given information about F double prime, why wouldn't you use the F double prime reasoning? What I don't want you to do is say, cool, I totally get the thing about F prime, so that's all I'll ever use. You'll get yourself into trouble. I want you to be flexible in your thinking. I don't want you to be rigid in your thinking and say, I can only think about it this way. Be open. Be open to the concept. Be open to what's really happening here. And remember, anytime prime is added to, F or F prime or whatever, you're just saying, what's the slope of that thing? So F prime is just looking at the slope of F. F double prime is looking at the slope of F prime. And that's really the foundation of which all of this is based on. Okay, so those are your two key takeaways. If you leave class today and you feel like you're starting to get the hang of those, that's a great thing. That's what we want. We good? Let's do some examples then. So here they are. And yes, I'm going to go in order here. Let's take a look at number 1. It says, find the points of inflection of the graph of f of x. Justify your answer. Before you just run into this and start trying, I want to make sure I give you some good direction as to maybe what you should be trying. Does anybody have an opinion on, should you, based on the way this is presented, should you be investigating behavior of f prime to answer this question, or you should be thinking about f double prime to answer this question? I think there is a good answer to this. What do you think, Hunter?
F double prime.
F double prime. I heard somebody else say F double prime. F double prime actually makes a ton of sense here. So that would be my first step. Figure out whatever F double prime is, and then use that key takeaway mentioned on the previous page to help you discern where any inflection points might be. What do you think? Does that make sense? This is where you ask questions. Reese, go.
For the inflection point, when you do 1/2, 0 for x, y, or just...
So unless otherwise specified, so let's talk about that. Unless otherwise specified, and I'll try to be super careful on quizzes and tests to say, find the x value of the point of inflection or the x value of such and such. Because I would say that for me to say that the inflection point, and I don't want to appear hypocritical here because I did misspell F with a G, so please forgive that. Now it's pretty. There it is. But I would say this. For me to say that the inflection point is at 1/2, 0 is actually likely incorrect. I haven't figured this out, to be honest with you. Where'd you get the 0 from?
We took it from y, just basically the 0 of f double prime. Would you plug
So that's the thing, though. So x is 1/2.
Would you plug that into f of x?
If you want to find the y value, you've got to input it into f of x, because your output would be a y value there. 0 is actually an f double prime value, is it not?
Yeah.
Yeah, so I would, that's why I said I'm usually really, really careful to say, find the x value of the point of inflection, because all I'll be looking for typically is just what's the x value. Unless we're looking for a maximum or a minimum, which we will later on, I'm not gonna be as interested in the y value because simply that's just kind of an extraneous thing to do. And I'd want you to avoid making a mistake like that. So, great question. Joe, is that the same question you had?
Yes, that is.
Okay. Anybody else? Okay then, let's take a look at number 2. Number 2. Number 2 looks like this. Number 2 says, given a graph of G prime, determine the inflection points of G. Justify your answer. So that justifying your answer is when you say, I think the inflection points are here and here because the thing that comes after the because would be your justification. So it could be tricky. Please remember you are given a graph of G prime, not a graph of G, not a graph of G double prime. So having these key takeaways super duper solid in your mind will certainly be a key for you.
Do they apply to sharp points too, or?
So the wording on like the key takeaway thing is not, so the thing I said with Hunter, like his statement was actually totally true, but we can find counterexamples to that. The key takeaways I gave you, you can't find counterexamples to that. And we can talk about that sharp point, because a lot of people really do hesitate and they say, oh my gosh, what does this sharp point mean? Because we're definitely accustomed to the idea of sharp points get our attention. And that to me looks like a very sharp point. Does it matter? Maybe it does. Maybe it doesn't. I joked about my little oops with the F double prime and the G double prime. I think in that example, because there was only one function with which we were working with, I think typically that's going to be okay for us. But there will be times, as you can well imagine, like with chain rules and all sorts of different functions going on. You might come up to a question, we've already had it, where within one question there's an f of x, a g of x, and an h of x. In a case like that, if you happen to misspell like I did, that would be a problem. So do be careful with that. I'm a little embarrassed that I misspelled F with a G, and I should know better than that. We've been writing G's and F's for a long time. All right, if you're ready, looks like some of you are. Here is a solution and a justification. And let's discuss if there's any questions. Like if your question starts with, wait, I thought this, but you wrote that, that is a wonderful place to start your question off. So look at what I wrote. Think about what you wrote. Do you have anything you want to talk about? Let me know. Is anybody catching on to the fact that these key takeaways could easily be mixed up? Or really, really work at it. I've had students in past years that made flashcards for themselves, where on one side they put when f prime is positive, and on the other part they put, on the other side they put f is increasing, like that kind of thing. You could flashcard yourself while you're walking to chapel, while you're eating lunch. If someone happens to drive you to school, I don't know. Whenever you got a spare couple of minutes, I'd be flashcarding. I recommend this simply because they work. They take a little bit of time to make, but they work. It's hard to dispute that. What do you guys think? Any questions? Anybody concerned about the sharp point? Let me put it to you like this. I've heard, I'm sure you can imagine, over the years, many, many times, people will see that sharp point and they'll say, oh, at x equals -1, we have a sharp point, therefore, blah, 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 fill in the blank, doesn't exist. They see that sharp point and they're just like, oh my gosh, the world just stopped because there's a sharp point. If I try to find G double prime, wouldn't G double prime not exist at -1? the G double prime would still switch signs, wouldn't it? It'd switch from negative to positive. Let me put it to you another way. Sometimes people will look at that sharp point and they'll say, oh man, does that mean that G does not exist at -1? You guys remember differentiability implies continuity? Is that a continuous graph?
Yes.
So the fact that G prime is continuous, doesn't that imply that G is not only continuous, but it's also differentiable? Right? The fact that that's continuous means that G is differentiable. Okay, nobody had any questions? Let's do number 3. We might get through most of our examples today. How lovely is that? All right, here is number 3. So maybe you can see how you have to be nimble. And number 3, once again, I gave you a graph, but this is a graph of H double prime this time. H double prime. We're supposed to identify the x values of any points of inflection of H. Graph of H double prime is shown. What are the inflection points of H? So let's justify your answer. So let's practice. You're going to say H has inflection points at blah, 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 because the because is super important. Here it is. H has points of inflection at x equals -2 and x equals 3. Because H double prime changes from positive to negative at -2 and from negative to positive at 3. Did anybody include 1, x equals 1 in the mix? If you did, somebody might have said, hey, at x equals 1, H double prime is 0. H double prime being 0 is not an indicator of an inflection point. H double prime actually has to actually change signs. So x equals 1 would be almost, but not. Guys, how are we doing? Making good connections? All right. So then I've got the one last one to do here. It's number 4. So if you guys could flip over to number 4. There it is. So I've given you an expression for f double prime. It's written out nicely and factored. It's extremely helpful. We're going to try to find the x values of any inflection points of f. And again, we're going to try to justify our answer. While you guys are doing this, I know that on our previous efforts with trying to relate f with f prime and f double prime, there have been a couple of examples that we've had to leave undone simply because of time. What I'm going to try to do here in the next, the next couple of days, I'm going to go back and let's basically make a video for kind of the Island of Misfit Toys, right? The questions we didn't quite get to. I think they're good, and I think as you think about studying for some future quiz involving this, they'd be good for you to go back and try. And so I want to supply you with hopefully some quality solutions in which I don't misspell f with g, and give you some good answers, but I'll be making that video in the next few days. I'll post it and I'll let you know where you can find it. Good luck, Luke. What are you playing?
Where or what?
What?
2 originals.
Oh, 2 originals. Awesome. Have fun. It goes great. Okay, so let's discuss. I think I've got a solution up here for you. Here we go. So notice I made a sign chart. I was just walking around peeking over shoulders. I saw a couple of sign charts. This would be an F double prime sign chart. Would encourage you to use that as a graphic to help you get organized. You don't have to write it. It's not required at all. You can use it if you want. So I found the zeros of F double prime to be -4, -3, and 2. And then what I did personally is I tested the left interval. I think I must have plugged in a -5. And I got a positive times a negative times a negative, which is a positive. And then I just used multiplicity from there on out. You could test out each individual interval yourself. I just used multiplicity to get there. We can discuss if you want. So then I got F double prime changing signs only at -4 and -3. Kaylin, your question?
So I messed up the sign chart and I don't know why. Like,
Okay, so what I did, yeah, so what did you test out? Like what number did you plug in to test?
-5.
Okay, let's start right there. So F double prime of -5. And I'm just going to think about this as pluses and minuses. I'm not going to worry about the specific numbers at this point. So if I plug in -5 here, I would get a negative number squared. So that's a positive. And then here, -5 plus 3, of course, is -2, which is a negative. And then if I plug a negative into that last factor, -5 plus 4 is negative, to the 5th power is negative. So a positive times 2 negatives gives me my positive right there. And then, like I said, I just use multiplicity. And if you started off your one interval wrong and then use multiplicity, you're going to be wrong on all the other ones too. And that might be an argument in favor of not using multiplicity, right? Because you could test out the other intervals and be like, whoa, something doesn't make sense, and then you could reconcile that. But as long as you start off right, then, I just said -4 has odd multiplicity, -3 has odd multiplicity, but 2 has even multiplicity, and either went through or bounced accordingly.
Okay.
Does that make sense?
Yeah.
Okay, thanks for asking. Anybody else? So let me say this before we go. We're kind of done with our key takeaways for this unit. You go back and look at the last several days. There have been key takeaways on each day. It's at this point I would so strongly encourage you that once we kind of finish our test cycle, please, for goodness sake, make some flashcards and flashcard those key takeaways to the point where you have them mastered. Not like amateur or almost like Olympic level mastery, not JV level mastery, but Olympic level mastery, and future quizzes will go really great for you. So anyways, have a wonderful day. Appreciate working with you guys. See you tomorrow for a review and then test on Wednesday. Have a good one, Hunter.